Hi everyone, Miss Meek here, and today we are going to combine everything together that we have so far talked about when it comes to algebraic relationships. And so we're going to talk about multiple representation. And what that means is that we are going to represent the following algebraic relationships multiple ways. So multiple representations. We're going to use tables, we're going to use graphs, we're going to use equations. We're going to talk about the independent quantity and the dependent quantity and which one's which and all of that. Like I said, combining everything together that we have learned so far in our algebraic relationship chapter. So let's go ahead and get started. Here is the first problem. It says a goose can travel 6 miles m per hour h. Now something real quick before we continue on, notice that they're giving us the letters that they want us to use. We have m for miles and then we have h for hours. So instead of using x or y or some of those common variables that we have been using, we're now using specific letters for our problems. The directions say to make a table, write an equation, and graph this relationship, and then they want us to analyze the graph. So let's go ahead and jump in. I will tell you the easiest way to start these problems is to make a table first. From that table we can build the graph. From that table we can figure out our equation. So I'm going to draw a very simple table here. And let's think about where our different numbers are going to go. Okay, it says 6 miles per hour. So think about it. If they travel 1 hour, that's 6 miles. Okay, if they travel 2 hours, that'd be 6 plus 6, so that'd be 12 miles. 3 hours would be 6 plus 6 plus 6, which would be 18. So the thing that I'm changing is the hours, and when I change the hours, it affects how many miles this goose has gone. So that tells me that my hours here is going to be my input. So hours, or H, the letter we're using here, is going to be our input, and the outcome, the result, is how far this goose has traveled, and that would be the miles, which is going to be our output. So that's the answer that we're trying to get. So let's pick some values, make it easy on yourself, pick some really friendly numbers. So I'm going to pick like 1, 2, and 3. And it already told me that if I travel 1 hour, that is 6 miles. Okay, so we already know over here that 1 hour is going to be 6 miles. Well, what do I do that 1 to make it become a 6? Well, think about it. I'm multiplying maybe 1 times 6. I could be adding 5, but think about our problem. Does it say anything about 5? Like the goose is traveling 5 miles every hour that it spends? No, it doesn't say anything about that. It talks about miles per hour. Another clue that I'm multiplying is this word per. That means for each hour, which is a multiplying word. So every hour I go, I'm going 6 more miles. And so that is repeated addition or multiplication. So in this, what's happening is I'm taking these H's and I'm multiplying them times 6. So let's go ahead and fill out the rest of our table. So again, my rule is going to be my H, and I'm going to multiply it. I'm going to multiply it times 6. So the first number was 1 times 6, right? Got me my 6. Now we're going to plug in the 2 and do 2 times 6, which is 12. And then our last one is going to be 3 times 6, which is 18. So again, I took those hours and I plugged them in right here and multiplied them times 6. So this right here is our rule. Okay, this is our rule. So from my rule, I can make my equation. All right, what we're doing to these H's is multiplying them times 6. So we're taking our H's and we are multiplying them times 6. And when we do that, it equals that column on the right side, which is our M column, or our miles. So this equals our miles. So there's our equation. M is going to equal 6 times all of those hours, those H's. Okay, our input there. So let's go ahead and graph it. Now, we have to label our graph. So remember that our independent variable is always on our x-axis. So just as a brief reminder real quick, this is our x-axis, and this is where our independent quantity goes. This is our independent quantity or our input. And for this problem, that is our hours. So the hours, I need to scoot that down a little bit because I got to put my numbers. These are our hours, H. And then our y-axis is our outcome or our output, our answers, our results. And that's going to be over here on our y-axis. So the dependent quantity or the output is over here on our y-axis, okay? And so that is going to be labeled miles. Again, I need to scoot that back a little bit so I have room for my numbers. So again, you got to put those labels on your graphs now that we have words to label it. So I'm going to go ahead and plot these points. So the first one is when x is at 1. So actually, I probably should label some of my graphs so I know what I'm doing. So I'm going to go ahead and label the x-axis by 1s. Oops, that 3 is over too far. Let me fix that real quick. There we go. And then I'm going to label my y-axis. I'm going to go by 6s because that's what my table is going by. So we're going to have 6, 12. Sorry about the space there. It's kind of cramped. All right, and so I'm going to go ahead and plot these points. So my first one is over 1 and then up 6, so right there. My next one's over 2, up 12, over 3 up to 18. And then remember, we want to connect those dots and add an arrow on the end because if my graph was bigger, my line would continue to increase that at that same rate there. And so there is my graph. Now the last thing they asked us to do is analyze the graph. So let's talk about it. Is it a straight line? Okay, yes, it should be. Now, we learned about a vocabulary word for straight line in this chapter, which is linear. So we can say that this graph is a linear line, meaning that it is a straight line. We can also say that it's increasing because it's going up. If it was going down, that would be decreasing, but this guy is definitely increasing. It's going up, meaning that as my hours get bigger, so does my miles. Everything is increasing. And we can talk about how this is actually increasing by 6 miles each hour. Each hour. So every time that I go over an hour, I'm going up 6 miles. So if you notice right here, I go over an hour and then I go up 6 miles. I go over an hour and I go up 6 miles. So that means that we are increasing by 6 each time. And so those are things that we can say to analyze the graph. Sometimes they also ask us about which is the independent, what's the dependent. So we could also include that in our analyzing of the graph. We could say that hours would be our independent and that miles is our dependent. So those are all good things to write in your analyzing of the graph. Let's do another one. So this one says Miss Meek charges $7 more than the number of tomatoes bought at her farm. Make a table, write an equation, and create a graph representing the relationship between C, the cost of buying T, tomatoes. So again, they're telling us the letters to use. They're asking us to use C to represent the cost, and they're also asking us to use T to represent tomatoes. So they're giving us the letters to use, which again is something different than before. So let's go ahead and start off by making our table, because from our table, we will actually be able to make like the equation and make the graph and everything else. So first step is what is changing what? What is affecting the other thing? Because remember, we have to identify what's our input, so what's the thing that's changing, and when I change that thing, what is it affecting? Because that's going to be our output or our result. So what are we trying to find? Well, we're trying to find how much I'm going to be spending on tomatoes. So if that's the thing that we're trying to find, that is our outcome. And so that means that the cost is going to be our output or our dependent variable here. And then over, what are we changing? Well, if I buy 1 tomato, that affects the cost. If I buy 2 tomatoes, that affects the cost. If I buy 3, 4, 10, 1,000 tomatoes, that affects the cost. So the thing affecting the cost is how many tomatoes I'm buying. And so that is going to be our input over here, tomatoes, which is represented by T. So let's see what it says that we're doing to these tomatoes and the cost. It says it's $7 more than the number of tomatoes bought. So $7 more than. Think about what operation more than could represent. Adding, subtracting, multiplying, dividing. Okay. If I'm doing something more, I would think that we're adding to it. And so more than means that we are going to be adding. And we're adding $7 to the number of tomatoes. And we know that this number of tomatoes is represented by a T. So we're going to be adding 7 plus T. That is how we can kind of come up with our rule from the word problem that they're giving us here. So if I buy one tomato, it says it's $7 more than that tomato. So the math that I'm going to be doing is 1 plus that 7, and that's going to give me how much money I have to pay. So $8 in that case. Okay, so again, if I buy 2 tomatoes, it's 2 plus 7, and that's going to equal 9. If I bought 3 tomatoes, that would be 3 plus 7, which equals 10. So honestly, if I was buying tomatoes, the more tomatoes you buy, the better deal you get, okay, with this. Because no matter how many tomatoes you buy, you're paying $7. So the rule here is going to be our tomatoes, T, plus 7. And again, I made up some numbers of tomatoes. I made up some T's for that first column there, plugged them in, and that's how I got the cost. And these are the things that I'm going to be putting in my graph and plotting here in just a second. But let's go ahead and write the equation. Remember, the equation is what is happening to my T's. So I'm taking T and I'm adding 7 to it. That's my rule for the table. And what does that equal? Well, it equals how much I have to pay for tomatoes, which is C. So our equation is C equals T plus 7. Now we're going to go ahead and graph that. I'm going to label my numbers first this time around, so that way I make sure that I have plenty of room. I'm going to make my graph over here. Let's see, we can go 2, 4, 6. That will be too small. I guess we can go by threes. 3. Well, let's see. What would be? I guess we could go by 2, so that would be fine. 2, 4, 6, 8, 10. Yeah, 10 will fit. I wanted to make sure 10 fit. And we want to label our graph. So remember, our independent is going to be the number of tomatoes down here. This is what I'm plugging in. And then my result, my answer, my dependent is the cost of those tomatoes, which is represented by C. Remember, tomatoes is represented by a T. And so we're going to go ahead and plot those points. So I go over 1 tomato, and then I go up to $8. I go over 2 tomatoes on the x-axis, and then I go up $9, which is going to be right here in between 8 and 10. And then for 3 tomatoes, I go up all the way to $10, and I connect those dots with a line. And now we're going to analyze the graph. So again, is it a straight line? Yes, it is. So we can say that it is linear. It's a linear line, meaning it's a straight line. Is it increasing, meaning is it going up? Yes, it is. It's not going up very much each time, so it's not super slanty. It's kind of flat, but it is increasing. And so let's see if we can determine how much it's increasing by. So every time I go over 1 tomato, I go up 1. So it's increasing by $1 actually each time, by $1 each tomato. And then we can also talk about the independent, the dependent. So we could say that the independent, I'm going to abbreviate independent, is the number of tomatoes. And then we can say that the dependent, abbreviating dependent as well, is the cost. So again, those are all good information to put into your describing the graph and talking about what's happening in your graph. All right, guys, so this is everything mixed together from what we have learned so far about algebraic relationships. I hope this video helps clarify some of the different things that you can write about your graphs, the tables you can make, the equations, how you can use different letters than just X and Y. And I will be talking to you later. Bye.